So basically, in today's session, we start with the exam prep for you guys. So what we will cover is what we will cover is an exam paper. So if you have other exam papers that you want us to go through, please send me a WhatsApp with a paper, or you can email it to me. Then we can work through it. So all my info is on here. Yeah, so by all means, please, if you have any old exam papers, any questions, if you have taken picture of certain of the questions, or from other papers or assignments have it, you can always send to me. Okay, so basically I'm going to go through a few types of questions. So I'm just going to go on because I know there is some issues with people joining. So if you guys join again, we basically just continue with this. So this is all part of your first part of the session. So if you look at your study unit 1 and 2, so the first few will be focused a lot on some of those. So let us quickly start. So when you get a question like this, where you need to simplify it, what I normally would do is to group things together. Rebecca, I am recording, so if you have issues dropping off again, don't worry. I will share the recording again on our WhatsApp group later tonight. So if there is connection issues and you drop off, don't worry. I will continue, and I will record, and then I will share it later on. So don't worry too much if you drop off. Okay. So the first question is basically looking at something that you need to simplify expression. But the important thing when we do simplification is when there's the minus or plus between terms, we can only group terms together if they have the same symbols in it. So when we look at A3, no other one has A3, so that will be something that we will need to just rewrite. So we can't add any of the others with it. So when we nearly look at answer sets, with A3 being what it needs to be, we can already eliminate one of them. The next one nearly is to see, okay, let's group all the A2s together with a B. So all the A2s with 1b, so there's minus 5 of them there. A2b, A2b, so there's another minus 2. So minus 2 minus 5 is then minus 7. So then at least we've got that A2b covered. That's B2, so we need to do it separate, and that's B2. So by just looking at those first two, now I can go and say, okay, well, A2b, it needs to be minus 7, so that's not the option. A2b, there's not one in there, so that I can nearly cancel out. Here we sit with A2b, so at the moment it looks like option 3 will be the one that we will select in the end. But now let's do the next one to say, but okay, let's look at everything that has a and b to the power of 2. So we've got a 10 there, minus 7, so 10 minus 7 is plus 3, a b to the power of 2. There we have it, and then the last one is plus 14 b to the power of 3, which is also. So for this question, when we started simplifying, the important thing is that always look at what you can group together and what you're not allowed to group together, because in this instance, all the terms are split by a minus or a positive. We can't group things together that as not the same A and B's. Okay, so the correct answer was option 3. The next one is a bit different. So here now they give us a multiplication, and then there's a form that we, if possible, we need to subtract. I was wondering if this was not a division, because if I looked at those answers, but let's first handle it as minus, and then let's see if we subtract or if we divide, if we might then get one of these. Okay, so in the beginning of all the study units, nearly, we looked at exponents. So, and we had where the exponent was 0. So whatever we have, so y to the exponent of 0, a to the exponent of 0, 5 to the exponent of 0, that will always be equal to 1. So the thing here in brackets is then 15x to y to the power of 3 times 2 times 1. Okay, so then actually that becomes 30x to the power of 2y to the power of 3. So let us say this was division, because you can't subtract 30xy and 30x to the power of y, or x to the power of 2y to the power of 3. So it was probably a division and not a subtraction. So then if we just write it out in what we have currently, we have 30xy divided by what we've calculated here, the 30 x to a power of 2, y to a power of 3. So first thing we can do is say, well, 30 goes into 31, so we basically have that at the top. Then we can say, well, x goes in there, and x goes in there 1, so that instead of 2, that becomes 1. That also disappears, so instead of 3 here, this becomes 2. So at the top you have got 1, and at the bottom you've got x y to a power of 2. So we could have written it also just originally, so that you can see how we 2 minus 1, because we bring down the 1 from the top, and y 3 minus 1, because we bring down the 1 from the top. So we could have rather rewrite it like this, and then from there we could have just rewritten it to a power of 2. So let's just check. There is 1 over xy to a power of 2, 2y over x, and no, that's not. We would have, if we didn't know what to do with a 2y to a power of 0, and we made that whole thing 1, we would have gotten the 2 over xy to a power of 2, and I don't know how we would have gotten that one. But if we set this whole thing was equal to 1, then we would have gotten that as a possible answer. So also very important to remember and go over the exponential rules. That was very early in the subject that we did the exponents. I think it was even in chapter 1, if I can remember correctly. But definitely there was mistake, so it must have been the 30xy divide by, and not minus. Because if it was minus, the answer would have been none of the above, because you couldn't have done anything with it. Okay, so another expression that, so you can definitely expect a few of these in your exam, but please, if you have exam papers that you want me to go through, please send it to me. Send it. You can even put it on WhatsApp. If you have questions that there's like a one question that you also want to send to that, we've got some time to go through in the next few Wednesdays. We've got enough time to go through if you have any questions that we need to look at. Okay, so with this one, again, we need to simplify. We've got the minus, and then we've got the multiplication. So what we're going to do is first work with this term that has a multiplication, and then subtract and see if we can subtract that from the first term. So when we multiply the second term and the third term with one another, we get 15 times 2, which gives us the 30. We've got x to the power of 2. And y to the power of 6. So again, if this is my first term and that is my second term, this is where I needed to stop, because again, you can't subtract x to the power from, or x to the power of 2 from x to the power of 4. So again, it's different if that was again divided. So let's just see if it was supposed to be divided. Then we just write it above and below the line to see what we can eliminate. But so definitely a copy of a paper that I had was very, very badly copied, but it didn't see those kind of things. Okay, so again, 50 goes into 51, 50 goes into 51. So for now, let's say above the line. Then x to the power of 4. So if we want to bring that to the top, we can say minus 2. And at the bottom, we rather bring that down, because then we can say 6 minus 3. So then at the top, it would be x, 4 minus 2 is 2. And at the bottom, it will be y, 6 minus 3 is 3. So if you then needed to rewrite it, but first I would check if any of these are correct. So let's see. No. Mm, None of them is actually correct. That's quite interesting. Yeah, so again, probably there was a mistake, but none of them is actually correct, because you've got x to the power of 2 over y to the power of 3. So probably one of those two needed to be rectified or changed to get to the answers we're looking for. What you can also, and this is where I in one of the previous sessions said, also let the answers guide you, because sometimes what they could have done was that this might have been a final answer as well. So depending on how they structure your answers, or it might be just with the positives at the top and the bottom, or you can rewrite it as all in one term as well. So all depending on nearly how your answer set look at the end. Normally this is how they would nearly have it. You can see they would nearly put it in the fraction instead of making the one a negative. So we would normally do it with a fraction that both are positive. Okay, so that was the expression. So that was your first part of I think it was study unit 1 nearly. And then study unit 1 from equations go into or from expressions into equations. And then you need to start solving x. So this one is, and you will see there's a few that we will now cover on equations. So the first one here is nearly, what's the easiest for me always is to bring all the x's to one side and take all the constants, or the ones that don't have an x, to the other side. So I would want to bring all the x's to your left-hand side. So I've got 2x, and this will take to the other side, so it becomes plus x. And on this side, I will have 3 plus 3. Okay, so that was for 3, and I take that over to the other side, so it becomes plus 3. So 3x is then equal to 6, and we then solve x is equal to 2. Okay, so there was option 2, but let's put it just back into the equation. So 2 times 2 is 4. 4 minus 3 is equal to 1. Okay, so let's put in 3 minus 2 is also equal to 1. So just if you want then to test your answer, you can always put that x value that you calculated back into your equation and just test it. So here we tested it by putting it back into a left-hand side, which will give you minus positive 1. And when we put it into the right-hand side, we'll also get positive 1. So then we know at least the x that we've worked with is, or the x that we got is correct. Okay, but that I normally also, just to make sure that you get the marks and you don't make a silly mistake or something like that, I always go back and just test it to see if the calculation I made was correct. Okay, so again asking us to solve for the equation, but now what they've brought in is brackets, so that they can test that you guys know that we need to do brackets first. So we need to multiply the 2 in with both numbers. So 2 times 2x is 4x. 2 times minus 1 is minus 2, and that is equal to x plus 1. So again, like the previous one, I want to bring all the x's to my left-hand side. On this side, it will be 4x minus x, and then on the other side, it will be 1 plus 2. So then we'll get 3x is equal to 3, and x is equal to 1. Okay, and then again, I can test it. So let's put in it in x's place. So 2 times 1 is 2. 2 minus 1 is 1. So 2 times 1 is equal to 2. So let's just check then on this side. If we have 1 plus 1, that is also equal to 2. So we can then also see that the left hand and the right hand is exactly the same. So our final answer then is definitely x equal to 1. Okay, so now what we've done is and that is nearly how your study guide is also set up. They start with the expression, then they do equations, then they throw in a bit of word sums. So now they're giving you a word sum, and you need to decide which one of the expressions is the correct one. Okay, so let's read it through, and then we can see what we need to do. The correct mathematical expression for a number which is 5 times as big as the number obtained after x has been decreased by 3 is. Sure. Okay, so the correct mathematical expression for a number which is 5 times as big as the number obtained after x has been decreased by 3. Okay, so 5 times as big, but after x has decreased by 3. Okay, so 5 times as big after x has been decreased by 3. Okay, so that will be our correct one. If what the first equation is saying, it will be 5 times as big, and then you subtract 3. Instead of reading it as x has been decreased by 3, and then you make it 5 times as big. Let me quickly, x minus 3. Okay, so that is also fine, the x minus 3, but instead of 5 times, they said plus 5 or 5 more. So not the times that they're saying, but if that was a multiplication, it would have been exactly the same as option 2, but not just adding 5. And then I don't know what what they did with the last one, how to get to x minus 15. I could have just said 5 times 3 or something like that. Okay, so this is where they ask you just to write the expression. They could have said to you, well, this answer is 60, and then you need to solve the answer as well. So that they can also do in your test. So I will check for more of these types of questions that we can do next time when we do more revision work for your exam. Okay, so those were around equations and those kind of things. What also is included, and you would have seen that also starting in study unit 2 and 3, is when we look at expressions, but we nearly put it into the terms of something different. So in this instance, they ask you, so a motorist travels at a certain speed, so he travels 200 kilometers in p hours, and then they ask you as an expression for the distance which was motorist travels in x hours, so we will just multiply by x. So this will be the formula that we will look at. So motorist travels, so if he traveled 270 kilometers in 3 hours, then if he then travels 5 hours, we will multiply it by 5. So that is why this formula works very nicely. I just want to see if, okay, so that one could have been correct if it multiplied by x. So that was just, and those two also then just swap it around. Okay, so but option 1 is the correct one. And think about it as one would normally say you drive 120 kilometers per hour. So when we do that, let me just, so if we said we traveled 120 kilometers per hour, then it would have been 120 kilometers, and if that hour was 1, then it would have been 120 divided by p. So if we then travel for 5 hours, we know that we have traveled for 600 kilometers. So when you get a question like this, and sometimes they use different terminology, try to make it more practical in the things that we normally would talk about. So we would talk about you travel 60 kilometers per hour in a normal area. If you're on the highway, you travel 120 kilometers per hour. So that nearly one can already see if somebody then tells you, okay, well, you drive 260 kilometers in certain hours, it will be that you will divide that 270 by how many hours you would have driven, and then to make sure you get the full amount of your traveling, you will multiply by the X hours that you were traveling. Okay. So a bit of a different question, but again, try to make it a bit more simpler by merely bringing it to the things that we actually understand. Okay, so now we go into, and let's just see if I can make this a bit bigger, into the dimensions and measurements. So some of it they want you to do a circumference. There's another one that you need to work out the area. So let's see if we can do that. So for working out the circumference, circumference, sorry. Basically we need to add all of these sides together. So if we can do that, then we can get to all of the answers. So the easiest one nearly is to say, okay, well, I've got a 10 there, I've got a 10, so here's a 10, there's a 10. So if I look at that part and that part, and that, then at least we already know that is 40 centimeter. Okay, so if I look at my answer set, anything of those can still be possible. So now I need to work out what that is, and it is exactly the same on that side. So if I work out what that semicircle is, I can just multiply it by 2, so then I get both sides. Okay, so now I need to remember what is, I'm actually going to Google this now. What is the circumference of a circle? I know it is in the study guide. Okay, so circumference of a circle, and I'm actually gonna copy it in here for you guys. Again, you can use the previous work that we've done, just to make it easier. So circumference of a circle is 2 pi radius. So if it was half a circle, it would have just been pi radius. But because we actually want full circle, we can keep the 2. So it's 2 times pi, which is 22/7. And your radius is actually only 5. Okay, so let's see if we can, at least if that is a bit a nicer number to work with. 22 divided by 7 times 2 times 5. So I get that is about 31,4. So if I add 51 plus 40, I get about 71 centimeters. So the closest is probably that option 1, which is 1,71 meter. Okay, there was 60. If we just said 10 plus 10 plus 10 plus 10 plus 10 plus 10, we would have gotten the 60, which is incorrect. If we said we're working out that, and instead of half a circle, we used a full circle, and on this side, we used a full circle as well, then we would have gotten 100. Okay, let me just quickly save. I don't know why we would have gotten 103 as an option as well. So you must just be very careful, especially with this one, where it was 2 half circles, that we don't use the full circle twice, because then we will get one of the other options. Okay, but for this one, we basically took the 2/4 sides that was available, and then we needed to work out the circumference of half a circle, plus another of the circle, so actually the full circle. Okay, happiness with a question like question 8. Does it make a bit more sense now that you've seen it as well and seen an example? Okay, so the next one then is very similar, the shape, but now we need to work out the area. Okay, so now it becomes a bit different. But again, there's things that one can hopefully make use of and take some shortcuts so that it's not that difficult. So the first one is for triangle, we're going to work with the formula of half base times height. So that will be the triangle. In here we've got not a square, but what is it? A rectangle. So for a rectangle, we basically use length times breadth, so that we will be able to do that. Then this one looks very similar to that one, so we can multiply by 2 that triangle because it's 8 and 8, it's the height of 6, 10, 10, so we will get the same answer. And then we need to add the area of the of them, so we can actually just take the full circle. So again, I'm just quickly googling what area of circle formula is. So the area of a circle is pi radius to the power of 2. Okay, so and we've got everything nearly for that. So let's quickly see for the triangle. We say half times base. So half times base is that. So that is 8 times 8 is, or 8 plus 8 is 16. And the height, that is where the 90 degrees height is 6. And it's exactly the same on this side as we said. So we can just multiply that by 2. So for the triangle parts, that will be, so basically 16 times 6 will be 96. Then for the rectangle, we've got 10 times 16. Which will give us 160. See, that is about 250. So that answer is already not part of it. And then for a circle, so weird that it doesn't want to draw the circle now. So weird that I can't draw there. So we've got pi radius to the power of 2, so 22 over 7. And again, radius half of that, 10 divided by 2, so it's 5 to the power of 2. So 22 divided by 7 times 25 gives us 78.57. Okay, so again, there's going to be something very close to that. So 78.57 plus 96 plus 160 give us a total of 334.57. Okay, so 5457, very close, but we've got the 334.5. So if I probably rounded that off a bit earlier, we would have gotten that answer. I really don't know what is happening with my PowerPoint, that sometimes it doesn't want to highlight, but we've got the answer as option 4. So this again, what I nearly did was you do it bit for bit. So there was the circle part that we did. There was the triangle part that we did. We needed to multiply it by 2. So that was the triangle part that we did. And then the last part was also adding the rectangle component. And then after you've calculated all 3 areas, you add them all together and you will get one of the answers. Okay, but I will check for you for more examples also on this, because I know they ask that every exam there is a question. There's basically 2 questions in the paper on area, on circumference, and sometimes there's one on volume as well. So I will just look if I can get some older exam papers, but again, if you have, please also share with me. Okay, so yes, the one that is to do with volume. I thought there would be one, but I thought they would have sketched it. But so let's look at this one. So determine the volume of a rectangle prism where it is 60 centimeter long, 35 wide. So let's do that, and then 10 centimeter in height. Okay, so that is, it looks something like that. And then we need to find out, if you look at liters, how many liters will be needed to fill this. Okay, so let's look at, so what we can do is say 0.6 times 0.1 times 0.35. So we've moved it, so let's just quickly see, we moved it from centimeters. So let's just quickly, move it from centimeters to, so there's 2 ways that we can do it. We can work it out as centimeters, and then we need to transform it into liters, or we make it from centimeters into meters, and then we transform it. So probably easier to say from the start to make it meters, but let's just see what we get first. So so 60 times 35 times 10. So this answer is centimeter to a power of 3. So let's just 60 times 35 times 10. So we get it as 21,000 cubic centimeters. Okay, so I know in one of the presentations that we did earlier, there was one slide that we had where we transformed centimeter into liters. Let's quickly, I'm just going to quickly see if I have something like that again, so that one can okay. Okay, cool. Yeah, I have something for you guys that we can put in here. Okay, so here's at least, let's just move this one. Okay, I doesn't want that to move, but that's fine. So what we've got now here is to say, well, so when we move from centimeters or cubic centimeters to liters, we will need to divide by 1,000. So we can basically say that divided by 1,000 will give us the answer of 21 liters, which is option 4. So please, just I'm going to check for you for other ones as well. This was where we transformed cubic centimeter into liter. I'm going to check for you when we work with meters and millimeters as well, and what we need to transform that in, but also backwards. So if they give us a liter or liters, how we need to transform it back into something else. So the volume one was a bit different because normally, and you can see for 21,000 cubic centimeter, there was also an option. So just be careful that there is, if we just worked out the total volume, we would have gotten one of the answers, and that is why I automatically added the centimeter cube to the answer, so that we nearly need to say, okay, but I've got cubic centimeter. I need to transform the cubic centimeter into liters. So I can't just say 1 cubic centimeter is 1 liter. Okay, so 1 liter is actually 1,000 cubic centimeters. So again, the volume one, they made a bit different, so that they can link it to liters and how much it will be filled. If you look at area, there's nothing that you can do around that, because it will be to the power of 2 or square. So there's nothing that one can say, but we're going to change the area into something else because you can't, because it's just square. But you can with volume change it into something that as a volume measurement. So that is liters. It could also have been kiloliters or milliliters. So depending on which one we work with, there's the link to liters, but also there will be links to other measurements as well. Okay, so that one was on volume, and then specifically the link from cubic centimeters to liters. Okay, and now we're going into a bit using the information around area, but then adding costing to it. So that we work out how big the area is in centimeter or in squares, and then we will need to multiply that with a costing to get what is your final cost. So let's look at this question. Calculate the cost of graveling a square. Okay, so the square we know is exactly the length of a square is exactly the same. So if the length is 32 meters, the breadth is also 32 meters. So we first need to work out what is this total area. That will give us an answer in meters square, and then it cost us 60 rand per square meter. So whatever that answer is, we need to multiply by 60 to get our final answer of how much we will need to pay. So area is 32 times 32, which is 1024. That is massive. Times 60 is 61440 rand that we will need to spend. So it will cost us 61,440 rand to gravel the of area, and that there is luckily an answer for that. Okay, so we first needed to work out what the area is. That we do by basically remember that the area formula is for square is length times breadth, but it's actually the same length. So we could have also said just 32 to the power of 2. So that gives us the 1024. And then because it's 60 rand per square meter, there is 1024 square meters that we need to cover. It is for 1024 times the 60 that we will get in the 61,000. Okay, so again, what I did with this one is you first needed to work out what the total area is, and from total area then you added a costing component. Okay, so let's see what's the next question. So the next one is now we're going into some of the things we looked at last time. So a bit of financial maths. just, while I'm chatting, I'm just putting in the link to the register or to the attendance register. I've added that now so that you guys can just say that you were in the session. But basically what, and this they love to ask in this in your exams is they tell you you're working with a formula and then you need to transform that formula a bit. So they give us the formula of the compound interest. Sorry, simple interest. So they give us the formula of the simple interest, where S was the one that we calculate, but now they want to make P the subject of the formula. So we will need to isolate P out of this formula. So the easiest to do that is to say, well, I'm going to divide on both sides with 1 plus RT. So if I divide on both sides by that, then that will cancel out. So on this side, I will sit with P, and then on the other side, I will sit with my S over 1 plus RT. Okay, so S over 1 plus RT. So there is the formula. So what I just did is I just wrote it down again, and then nearly telling myself, okay, I need to only look at P. So I need to isolate P. To isolate P, I need to get rid of this component. To get rid of that component, I will on both sides need to divide by 1 plus RT. Okay, we could have also, and let me quickly show you how to do it. So I could have said, but write it in the subject of R. So not P, not T, R. So I just want to show you how we would have done that. So again, I would have written down my original formula. Then I would have said, okay, sure, I need to isolate or get for R. So first, there's things in front of the bracket that I need to get rid of before I can work within the bracket. So on both sides, I would have divided by P. So then it would have been S over P. That would have been cancelled out. So I would have been sat with 1. Doesn't that want to? 1 plus RT. Then I'm like, okay, but I want to get to RT. So first I need to get rid of a 1. So I will subtract on both sides by 1. So then on this side, it would have disappeared. Then I'm like, okay, I want R to be my, so I need then to take that formula and we divide on both sides by T. So then my final formula of R would have been S divided by P minus 1 over T. And we could do exactly the same to if we needed to isolate t, we could have gone through the same process to do that as well. Okay, so I just thought it might be that you get something like this in also in the exam where you need to use one of the other ones. So at least we have that now as well. Okay, so we still got a few minutes, so let's quickly look at another question. So again, change the subject of a formula. So here we're sitting with C is equal to x over a minus b, and we want to change the subject to x. Okay, so the first thing I would do is I would say let's first get rid of a minus b. So to get rid of a minus b on this side, I'll on both sides add plus b. So on this side, then I've got minus b plus b, which will then fall away. So I've got c plus b. And then I would say, but I want to get rid of a, so I will on both sides multiply by a. So again, if we have ax over a, those two will disappear. So I'm sitting with ac plus b in brackets is equal to x. And now it's, like I said, with some of those previous ones, now I'm looking and I'm like, oof, I don't get one where there's brackets, so they want me to multiply in. So I need to then say, well, a times c plus a times b. I really don't know why I not working so nicely. So let's just draw it out here. So a times c plus a times b is equal to x. Okay, so there's a times b, a times c, so our option will be option 3. And again, to write ac or to write ca, no difference. The same to write ba or to write ab, no difference in the answer. So to write there ab plus ac is exactly the same. Okay, so again, needed to do some simplification, needed to change bits and pieces, so that in the end we could isolate the x. And this is probably a more difficult one that they'll give you to isolate, because you need to work with that fraction. So yeah, cool. So now another question where we basically will look at a cost function. So again, it will be saying, okay, you creating certain things, it costs you so much to, the input will be so much, what you will get for it will cost you, or your income will be a certain amount, and you need to work out what your profit is. And this one is quite interesting, because I don't know if we actually did cover the things of total cost equal to total revenue, and then profit is equal to total revenue minus total cost. I can't remember if there was something like this in BNU, and if it was just a small component of the equations, but you probably would have done it in one of the other subjects. So let's just see if there is something in here that we can use to get to the answer. So they tell us manufacturer produces 50 t-shirts per day at a cost of 10 Rand per t-shirt. So your variable cost is 550 times 10, plus there's a fixed component of 500, and then they said, well, you sell the t-shirts at 35 Rand per t-shirt. Remember, you made 50 t-shirts, so that will be your total revenue. So the 35 times 50 will be your revenue. So that is, why does it feel so little? This is all that. Total revenue 1750. Suppose you sell all the t-shirts he produces per day. Oh, okay, with 6 selling days. Okay, so that's interesting. I totally miss that one. So 50 times 10 is 500 plus 500, which is 1,000. It will be 750, but then times 6. Totally missed that. Times 6, which will then give us 4,500. Okay, so which is in option 4. I totally missed that we're looking at the whole 6 days that they can sell. That's why when I looked at it and I'm like, 750 is not even close to any of those. In the exam, I would have probably gone for that because I totally did not see that last one. If I said, if there was a number in it, I would have picked it up, but by spelling it out 6, I have misread that totally. So I would have in the exam probably said none of the above, even that we know that it's very seldom none of the above, just because I would have missed that 6 totally. So just be very careful also in your exams when you guys get these questions, to really read it till the end. I just read the profit, and even I read per week, but the 6 just didn't go into my brain at all. And if they probably gave me an option of 750, I would have probably gone for that also. So just again, be very careful and read the whole question. Okay, so this was a question basically around total cost, total revenue. When your revenue is more than the cost, you're making profit. So you can basically say total revenue minus total cost to get the profit. and just make sure that you do it for the right number of days in the equation. Okay, so let's do one more for the evening. Let's see. Okay, so this is quite interesting. So from nearly going into costing, we've done a bit of when we looked at interest rates. Now we go back to your lowest common multiplier. So phew, this is really shaking it up a bit. So we sit with 18, 36, and 27 as one of the things that we need to look at. And then we sit with 3st4, s to the power of 2, and 5t to the power of 2. Okay, so let's do this one first. So we sit with 18. So what I normally do is to say, okay, 2 goes into 18 in 9. 3 goes into 9 3 times. 3 goes into 3 once. So this one, we have 2 and 3 to the power of 2. Can that be? That's 9 times 2. Yes, okay. Then we sit with 36. And then we're going to sit with 27 as well. Okay, so okay, so 2 goes into 36, 18, 2 goes into 89, 3 goes into 9, 3 times 3 goes into, so here we sit with 2 to the power of 2 times 3 to the power of 2. So that is probably the one so far. And then it's 3 goes into 27. 9 times 3 goes into 9, 3. Okay, so here we sit with 3 to the power of 3. So our final one will be 2 to the power of 2 times 3 to the power of 3. And that answer is probably 108, but let's just make sure. 3 times 3 times 3 is 27, times 4 is 108. So automatically, nearly, with just doing this component, we could see that we're probably going to work with option 2 as the correct one. But let's look at the other one, which is interesting. I normally only have seen numbers and not that we used other equations and formulas as well to get to this. So the easiest nearly in here is to say, well, 3 goes into 3. There's basically that one will be 3. 2 goes into 4 twice, so there will be a 2 to the power of 2, and 5 will be 5. So on the constants, we already have 3 times 4 times 5 will, which gives me actually 60. And then on the other numbers, we sit with s to the power of 2 t to the power of 2. We're actually sitting with that one. 3, 4, 5. And that is 2 to the power of 2. It's not just 2. So this is quite interesting. And let me just check all the others. That is right. 4 times 9, that is right. And that is right. Okay, so this is quite interesting because I would have, and also just let me know how you would have done it. But for me, it goes to that all the correct too. I will just go through this again, but it feels to me it's that one and that one that we need to work with. I will just make sure and go through this again, but it feels to me it's those two. Definitely not 36 because, okay, so I don't know what your answer would have been for this one time then. But I nearly would have gotten 108 for the first component and 60 is to T2. But I will just go and check this out again. Okay, so that is it for tonight. Next time we will just continue with this exam paper, and then I will get us another exam paper, and I will just add that to this pack, and then we will just continue until we've done enough of this. So please, if you have also exam papers, please send it to me. If you have any